Hello everyone, welcome back to my channel, and in today's class we are going to be talking about something that's very important. Now this is load separation and changeover connection. It's all about how to connect the output of your inverter to the load in your house, knowing that you already have two supplies, one from the grid, then another from the generator. But then you are expected to add another supply point, which is the inverter, and you're supposed to also connect it to the house in a way that none of them is going to come in contact with each other, because when that happens the result is disastrous. Your guess is as good as mine. Now if you've not subscribed to this channel yet, this is the best time for you to do so. Just hit the subscribe button, hit the like button, and also share the video. And you can check back my previous videos for other lessons about the solar series, solar installation series, training on this series. Now let's just go straight. Now you can see that we have the a changeover switch here. This is an example of a typical changeover switch that we normally use for solar systems, for small and medium systems. Now, this is how it is. We have three inputs. The first one down, the one up, then the one in the middle. Now, this switch enables you to be able to switch between two inputs or two power sources. Normally, before you do any installation, this is how the setup is in your house. This is your house, this is the inverter. I've installed my inverter and my battery and all the connections. I've done that. Then we have outputs. You know, your inverter has outputs and it also has inputs. The output from your inverter is the power that your inverter is bringing out from the battery. Then the input is a space provided for you to be able to charge the batteries with the grid or a generator, like a backup charging system for your inverter and batteries. Your inverter is here and your changeover is here. Because most times when we install inverter systems, you always try to introduce a new changeover switch in order for us to be able to merge the generator, the grid, and also the power from the inverter to both changeover switches. I'm going to show you the steps involved in doing that connection and doing it rightly. Let's assume that you've already installed your inverter, you've installed everything, but this is what you met when you go to the house. Normally, this is the DB distribution box in your house where all the loads draw power from. Your ACs, this is the house. This DB is connected to the house. All the loads in the house, the AC, the fridge, the lights, fan, and etc. Then, this is the normal changeover you have in your house. You know, you can change over between the grid and the generator, just two power sources. It's very simple. You just put the grid on top, put generator at the bottom, then the output in the middle. Life goes to life, neutral goes to neutral. Then also the same thing for the grid, life to life, neutral to neutral. That's it. Let's go back to the inverter side. For us to be able to connect this inverter to the entire house without having a clash of titans between the inverter, the generator, and the grid, how are you going to do it? First of all, this is your output side. Connect the output to either part of this changeover, this new changeover switch, either the top or the bottom. Now, let me use the bottom part. Now, this is live, connect to live. Just take a wire from here. Let me connect neutral first. Connect the neutral from here. It's a simple wire. It connects here. Then take the live, connect here. So this is the output for your inverter. It's here now. So if you switch this thing down, it's going to provide power to these middle points. But there's nothing that can help us convey it now to the load, right? We also have this part here, empty. Now, the first thing you need to do after connecting the output of your inverter, you are going to disconnect this wire going to the DB from the normal changeover you have, because this one is only linking the generator and the grid. So when you disconnect it, I'm going to disconnect it. Disconnect that. Then take this connection to this point here, the top of this changeover. Now I'm going to connect neutral to neutral and live to live. So let's connect live. connect the life. Then the neutral, I will take it from here. Okay, I'll connect it here. Now, what have I done? I've moved the output from this point down to this point. I've already transferred the output of the grid and generator to this point. Right now, what we have here is inverter output, then grid slash generator. So we now have grid slash generator here, because with this you can also switch to grid and the output will come here as grid only. When you take it down, the output will come here as generator only. So we have grid on top, we have generator here. But when you take this middle point and you take it to this point, you already have grid and generator. So you already combined grid, generator, and inverter outputs. Right now, none of them is having a clash with each other. So this is exactly what I'm saying. Connects the the output of this is the output actually. The middle part is actually the output. Connect the output from your NEPA changeover to the top of your inverter changeover. So by doing so, you've already connected the grid and generator to one port of this new changeover. Now, what do you do with this output? You're not going to touch anything here. Grid remains on top, generator remains at the bottom. We've already taken the output to the top of this changeover. So right now, we don't have any business with this changeover anymore. No business. We are done with it. So all our focus has moved to this changeover switch. Right now, the output is here. Where do we connect the output to? We connect the output to the load, the DB, of course. Where else you want us to connect the output to? Because everything has been separated already. Generator, the grid has been combined to this part. Then we have inverter on this part. So when you take your output from here, this is life, connect life from, okay, let's connect neutral first. Connect neutral from here. It goes all the way to this point. Then you connect your live wire. Okay, let me draw it properly. It goes all the way to this point. That's all. So with this now, when you switch on the inverter, there's voltage at this point, and if there's lights or you have power from the grid, there's voltage at this point. So when you take the changeover up here, what happens? When you take this changeover up, what happens? Now the output comes here, and you can see the direction of the current where it's going to. It flows through these wires to the top of this changeover. So it's right here now. So it means there's voltage here. You understand? So this voltage, and there's also voltage here from the inverter. So we've transferred the voltage here to this side. So there's lights and there's voltage here, there's voltage at the bottom. So you can either switch between here and here. So when you take it up, you are using the grid at this point because this one is up. So when you take this one down and the generator is on, there will also be voltage here at this point. And it will come to this point as well. It terminates here. So you can either now take this one up or down. So when you take this one up, it means you are using either grid or generator. When you take it down, you're using the inverter. So it goes straight to the DB that connects to the loads in your house. So that's how to connect the load from your inverter's output to your entire house. That's number one. Then the next thing we are going to talk about is very important. It's called load separation, because most times, depending on the size of the inverter you use or you install, most times you are not going to always connect the load from this point, from this changeover, to everything in the DB. Because there are times if you install a 2.5 kV inverter or you installed a 1.5 kV inverter that can power at most a fan, a small fan, and you have AC in your house, you have two ACs and you have refrigerators and you have a one battery system, how are you going to connect everything to the DB? Because most times some persons do it, they will say they can control it whenever they want to use their inverter. They will just come here and switch off all the ACs, then change over to inverter, so there will be light in the house. Then If they sense that there's light, maybe they will install an alarm at this point, an alarm that will let them know, notify them that there's light, either from the grid. So when they install an alarm at this point, actually, this point, the top point, because it's just for grid. When they install an alarm and the alarm rings, they will quickly change over first to the grid on this point, then turn on the ACs and everything. You understand? So that's how they do it. But most times, it's only when you are very conscious of what you are doing, you know what you did. But what if in a situation whereby you are not at home and you have someone in the house, there was lights, and the person was using the AC, the fridge, and everything was on. And then they took the lights. Instead of the person to come, first of all, switch off all these things, you just go down, bring the chamber down to the inverter. And what happens? That's overload. The inverter will go down for it. You understand? So it's very important for you to do separation for small systems. Even some large systems, even if you do some 5 kV systems, 10 kV, what if the owner has about 4 ACs and 3 refrigerators? You at some point you still have to remove some loads. That's what causes load separation. The process of you removing loads from the DB, the process of you removing essential loads from non-essential loads is called separation. So the essential loads is actually meant for the inverter to provide power for even when there's no grid inputs, like the lights, TV, fan. But the non-essential loads like the AC, pumping machine, and maybe in some cases refrigerators, depending on the size of the system, we cut out from the inverter supply. Now, that's for that. Okay, one last thing. This is the input. We've not talked about the input. Where do you now get the input from? You are supposed to take direct current from either the generator or the grid. So this is where the generator and grid is. So you also tap from here. Just tap from here, take it to the input, and that's all. Or you tap from here. So that's all. You can either tap from here or you tap from here. It's the same thing. So when you tap from here, you take it to the input. So let me just draw it. Live. Okay, this is neutral. We take neutral from here. Okay, neutral comes here. Then you take your live from here again. Tap. I hope you understand what I'm doing. Live goes here. So this is a complete diagram of how to connect both the input outputs of an inverter already with the grid and generator you have in your house already for everything to be working perfectly and fine. You get the point? So that's for that. Then let's go to separation. You need to be able to know how to separate some loads from this DB. Now, this is the inverter's changeover. You recall that at this point, this is where the output of the inverter comes from, live neutral. Okay? Then this is your DB. Let me put the DB in the middle. Then this is your light changeover. Light changeover. This is the output. So we have here. And in DB we have plus and minus. Then we have now how is your DB connected? When you open your DB, normally you have a long span of metal that is neutral. You have screws where you connect all the wires to. Okay. Then you have breakers, circuit breakers, where all the red wires are connected to. And you also have a small metal connected to the DB as earth. Okay. Now we are all these breakers, we have wires going into all the breakers. All of these red wires are routed to different parts of the house. This one might be connected to an AC, this one AC, then probably this one lights, this one maybe some sockets, then this one refrigerator. Okay, then normally the neutral wires are all connected together. That's what we call common neutral. The neutral is not separated, it's only the live that is separated. So all the neutral wires are connected together in a ring. This is neutral. Then the live are normally separated to different blocks or different circuits or different rooms in your house. Now, this is the live, this is neutral. Normally, this one goes to the top of the changeover, as we've seen already. Okay, so let's forget about the top of the changeover. What our focus is right now is how to be able to connect this system and also do some separation in order for you not to overload your inverter. Let's assume that every other connection has been done already, in like we've seen in the previous diagram I drew. Now, I don't want these two ACs to be connected to this inverter's output. What will I do? What you do is this: before you connect this one to the DB, this is the DB plus and minus here, this is plus, this is minus. Before you connect this one straight to, because if you connect this one straight to the DB, you have connected both this inverter. Remember, you have connected everything to both inverter, gen, and light, all the ACs to a 1.5 kVA inverter, which is not ideal. Now, before you connect, you must first of all separate the load that you don't want to be on the inverter, on the DB. So you take it to the main changeover directly, connect it there, or you look for a box or a bus bar where you have plus and minus. You tap from this point, this plus, this minus, tap from this point, connect it to the bus bar, connect it to the bus bar. Now, then you remove one of the AC, locate the AC. Most times you use a multimeter to locate which is which. So when you connect, when you disconnect everything, you remove your fuse, just go to each of the sockets, take a wire, bridge the socket. Then when you go to the DB, use your multimeter, you run a continuity test between the neutral and each of the loads. Whichever one that reads through, just know that that's the particular wire that leads to that socket. So if you have two or three wires connected together, lose everything, test everything one after the other. I'm going to do a practical demonstration for this. Don't worry. I just want you to understand it by sketches first before we go to practicals. Now, so just anyone that reads through, disconnect it. So that's the particular sockets you're looking for. So assuming we found all the sockets, remove this one, remove this wire, remove the red, connect them together, then take a thicker wire and link them to the positive of this bus bar. That's positive. If you can also separate or trace the neutral and remove them from the neutral pin on the DB. Take it to the neutral if you can. But most times, a lot of persons do common neutral. So you take it to the what? The neutral side. It's the same thing. It's the same thing. It's the life that really matters. You understand? So except the wiring is not that perfect in the house because there are times where some persons miss polarity for different sensitive equipment. And when you do common neutral, you end up having problems, issues. So you have to be very careful. So if you did the wiring yourself, it's not supposed to be an issue for you. So you know what you're doing, you know that you're sure. If you do common neutral, it's not going to give you any issues. So remove the live or remove the neutral anyone, connect it to the separate bus bar if provided. So that one will give direct power to these loads that you've separated. And when you connect this one from here to DB, this live to live and neutral to neutral, is not going to give output from this point to these two loads we've separated already. So the only sources that will power these two loads are gen or grid. Only. There's no input here. These two loads will not work. So you've already separated them from the entire house. But if you don't do this separation and you take everything here direct to this place, everything will be active. So most times when we go to some houses to do installations, we find out that okay, it's not necessary to do separation because maybe the system can, on average, power everything in the house, fine and good. First diagram will work. But when you see that it cannot power everything, it's a small system, you must do separation. Don't let anybody deceive you and tell you that they can manage, they can handle it. No. Because when problems come, you're also going to be in the forefront, try to see, look for a solution. So you must try to avoid all of those things, try to perceive all these things and do the right thing before you leave the site. So do your separations, learn how to do separations. And again, if you can trace both the life and neutral and connect it to a different bus bar. If you cannot, connect just the life, it will work. And again, avoid common neutral for inverter inputs and outputs. Some persons is a very bad practice. We have the output for your inverter, they don't want stress, they only use one wire red to connect both. They will use red and connect it separately. But when it comes to neutral, they will just loop everything together. Is not a good practice, because most times some inverter they can backfeed through the neutral, and if you mix some connections in your house, and there are some electrical issues in the house, it will end up affecting the inverter. So avoid common neutral for your inputs and outputs for your inverter. But when it comes to the separation, you can use a common neutral and also try to test to see whether the neutral has some leakage current. If it has, you need to trace where that fault is coming from before you do your common neutral for the separation. So I think that's the end of today's class. Um, I've talked about pretty much everything you need to know for this particular topic, and I will try my best possible to follow up with a practical video to that effect, so that you see how it is done practically. I have some changeovers, some connections in my apartment here. So when I try to dismantle it and maybe try to reassemble, I will do a video and show you the process step by step. But it's also important that you understand how it is from the sketch. You need to be able to understand, get an idea at least. So thank you very much for watching. Please let me know where you're watching from, and also comment thank you in the comment section if you've learned a thing or two from this class. And also let me know the next topic you think I should make a video about. So until then, keep staying good, stay fit, stay well, and also remain blessed. Thank you very much for listening. Bye.